Hey class, so today we're going to talk about the money multiplier and T accounts. And basically we're looking at banking. We're looking at how banks operate, how banks make loans, and how that affects the money supply. Alright, so the first two things you need to know are just some vocabulary, assets and liabilities. So we talked about that before. Assets is what you own, liabilities is what you owe. And when we're talking about a bank, it's the same thing. So assets are going to be what the bank owns, what they have control over, and liabilities are basically what they've been entrusted with, but they might have to pay back. Now here's a little chart that shows you it's what's called a T account. It has a list of all the assets that a bank could have and all the liabilities that a bank could have. So under assets, you see we've got what are called required reserves and excess reserves, and we'll go over those. Loans, so money that a bank loans out, those are their assets. Government bonds, if the bank lends money to the government and so they own government bonds, that would be an asset. And then bank property, so the building itself, all the different equipment that the bank owns is also an asset. Now under liabilities, we've got demand deposits, and demand deposits, that's just a fancy word for like a savings account. So money that you deposit at a bank, the bank owes it to you because if you asked for it back, they would have to give it to you back. And so that's why it's a liability for the bank because they owe it to you. And also the owner's equity. So if the owner of the bank put some of his save some of his money in the bank, in starting up the bank, that would be money that the bank would owe back to the owner. Now the main things we're going to look at when we're looking at T accounts though are what are called the required reserves, the excess reserves, demand deposits, and loans. So let's get started. Demand deposits we talked about, that's money that people deposit at a bank, and it's a liability for the bank. They would have to pay it back to the person if the person asked for it, so they owe it to the person. That's why it's a liability. We also have what are called required reserves. Required reserves are money that the bank has to hold in their bank. They can't loan it out, and it's by law. And you might ask, well, why can a bank do whatever they want with their money? Well, think back to the Great Depression when you had the bank runs. Banks had loaned out so much money that when people went to the bank to withdraw some, they didn't have enough on hand, and so the bank ended up failing. So the Federal Reserve has what's called a required reserve, a reserve ratio, where they say that in America it's 10%, that banks have to hold back 10% of their demand deposits, have to have them on hand in the bank, so that if people went to the bank, there would at least be some money there for them to withdraw, and you wouldn't have those mass panics when the banks didn't have any money. Another example. So for example, if we had 20% reserve ratio, that would mean that out of all the demand deposits that a bank held, they have to hold back 20% as required reserves that they couldn't loan those out. So if someone deposited $100,000, $20,000 would have to be held in the bank, and then a maximum of $80,000 could be loaned out. Now the bank doesn't have to loan out all $80,000. They could hold back more of that. If they did, that would be called excess reserve. So any money that the bank holds on to that they don't loan out, but they don't have to hold on to that money, that's called excess reserves. And excess reserves can eventually be loaned out when the bank chooses to. So one thing I want to go back to real quick, on this T account that we looked at, the assets and the liabilities should always equal each other, at least for our purposes. Now in real life, sometimes there's a few extra scenarios that make that not necessarily exactly true, but when we are doing T accounts, okay, when we're doing math problems with T accounts, assets should always equal liabilities. Okay, so for example, if I tell you that someone deposits $100 as demand deposits, 20 and the reserve ratio is 10%, then required reserves are going to be 10, and then maybe loans are 90, or maybe excess reserves are 90. But your required reserves and your excess reserves and your loans should never equal more than what's in your liabilities area. Okay, and we're really not going to be working much with bank property or owner's equity. Tomorrow we'll kind of talk about bank government bonds, but just remember your assets have to equal your liabilities. For our purposes, they shouldn't be more than your liabilities. They shouldn't be less than your liabilities. Assets equal liabilities. Okay, so we're going to talk now about creating money. And banks can actually create money, which is by loaning out money, which is kind of crazy that they can just create money out of thin air, but they really can. And we're going to look at the process of how they do that. Okay, so say you've got this guy named Jason, and Jason has $100, and he takes his $100 and he deposits it at his bank. So at that moment when he deposits at his bank, If we were to count the money supply only consisting of whatever money comes from that $100, we would say we had $100 in our money supply. Now, if you look at the T account down below, you can see how it would be listed out. So when he deposits that money, there's $100 in demand deposits. That's a liability. There's $10 in required reserves because our required reserve ratio is 10%. Also, a little side note, if you're ever given like a T account like this and I ask you to tell me what the reserve ratio is, then you're going to use the required reserves and the demand deposits. Just divide required reserves by demand deposits, and that'll tell you what the reserve ratio is. But so the reserve ratio is 10%. We know that because required reserves is 10. And then at the moment he deposits it, the bank can't instantaneously loan that money out. So at least right now, we have $90 in excess reserves. And also notice that the assets equal the liabilities. $100 in reserves, $100 in demand deposits. So right now we have money supply of $100. A little kind of trick question that you might see is, whether he was holding that money as currency or as a demand deposit, the money supply was still $100. So if a question asks you, when he deposits that money, how much did the money supply change by right then? It doesn't change by any right then because $100 currency or $100 demand deposits, both of those are included in the M2 measure of the money supply. Now, let's say that bank then takes those excess reserves and eventually they make a loan to this girl named Sarah. Okay, so now on our T account, you see that that $90 that was excess reserves has now turned into loans. Okay, so now Jason has $100 in demand deposits and Sarah has $9 in cash. She actually can, she's holding $90 in cash that she got from that bank. So our money supply, remember, M2 is made up of currency and savings deposits and checking deposits and all of that. Now our money supply equals $190. Okay, the bank actually created $90 in money. But we could go even further with this, okay? Let's say Sarah takes that money to her bank and she deposits it, and then all that money that could be loaned out, 10% is kept in required reserves, but 90% is loaned out. Now, Jason has $100 in demand deposits, Sarah has $90 in demand deposits, and this girl named Amy, she now has $81 in cash. So now our M2 is $271, and the bank has created $171. But of course, we keep on going farther than that. We could say the bank then loaned money out to Bob, who deposited that money, and then the bank loaned that money, 10% of that out to Carly, who deposited that money, and then the bank loaned out, 90% of that to Rachel, who deposited that money. And if we kept going and going and going, I've stopped here at Tara at $47.84 with Tara. There's now $569.55 in M2. If you were to add up all these numbers right here, that's what you get, 569.55, which means that from that initial $100, the bank has created $469.55. And we could keep going even more. I just stopped because I got tired of, using my calculator to figure it out. The question is, though, how much money could the banks create? And basically, if they just kept, people kept depositing and it kept loaning out and depositing, loaning out, we could actually calculate it all the way until we reached, 0.1, or I guess it's just 1 cent, not 0.1 cent, but until we reached 1 cent, and we couldn't divide that anymore. That would be needlessly tedious, right? That would take, several minutes at least of multiplying by 0.9, by 0.9, by 0.9, by 0.9, and that's really just a waste of time. Instead, we have a simple formula that will tell us how much money the bank could create. And that's called our money multiplier. So the money multiplier shows how much possible, what's the maximum amount that the money supply could increase by from a single deposit. Okay, now there's a couple assumptions here. First of all, the assumption is that all excess reserves are loaned out, that every single dollar that the bank can loan out, they do loan out, that they don't hold any money in excess reserves. And the second assumption is that no money is held as currency, that when people take those loans, they deposit all of that money. Okay, now obviously that doesn't really happen in real life, right? Everyone holds at least usually a couple of dollars in their pocket or in their wallet. So this is really just a hypothetical maximum. Okay, I'm not saying that literally this is what happens, but this is a hypothetical maximum showing how much money is it possible for banks to create. Okay, and that's what we're calculating. What's the possible maximum that banks can create? So our formula for the money multiplier is the money multiplier is the reciprocal of the reserve ratio. Okay, so it's 1 divided by the reserve ratio. So for example, if the reserve ratio is 20%, which is 1/5, then remember when you're dividing any fraction, you just flip the second fraction to multiply. So the reserve ratio, or the reciprocal of 1/5, that would tell us that the money multiplier is 5. Okay, if the reserve ratio is 10%, 1/10, then the money multiplier would be 10. If the reserve ratio was 5%, which is 1 divided by 20, then the money multiplier would be 20. Okay, you can see it's pretty simple math here. But first we got to find our money multiplier. Then the actual formula is we're going to take our money multiplier and we're going to multiply it by the initial excess reserve amount. And that's going to tell us what the maximum expansion of the money supply could be. Okay, now we call this fractional reserve banking because the banks are reserving a fraction as reserves and then they're loaning out a fraction. They're not keeping all of their money as reserves because that would be silly because they couldn't make any profit off that because they wouldn't be loaning out money. So let's look at a couple examples. Let's say Jason, he had that $100 deposit. So the initial excess reserves, the initial amount that the bank held as reserves was $90, as excess reserves was $90. And the money multiplier was 10. So we take our initial excess reserves, $90, we multiply it by 10, and that gives us $900, which means that $900 could have been created from that deposit of $100. That was our increase in the money supply. That's gonna be a question you see a lot of times. That's gonna be the way it's worded. What's the possible increase in the money supply? And for this example, it would be $900. Now, make sure you don't get tricked up. Sometimes the AP tests ask a few different worded questions that you might do one formula when they're really asking you to do something a little bit different. Okay, so the new money, the increase in the money supply is $900. But maybe they might ask you, how much money is in the money supply now? Okay, well, we have that initial increase of $900, but you also have to include the original $100. So the total M2 money supply is $1,000. Okay, notice the difference. The increase is $900, but if you include that original $100, the total money supply is $1,000. Okay, make sure you don't get tricked up by those. Always make sure you read closely. Is it asking for the increase in the money supply, or is it asking for the total money supply? Okay, it's a little different whenever we look at how the Federal Reserve interacts with banks and when the banks are buying bonds or selling bonds to the Federal Reserve. In that way, banks can also create money, but you've just got to make sure you include something else. But that's something we'll kind of take a look at tomorrow when we look at monetary policy. Okay. All right, guys. So that's all I have for you today. I will talk to you tomorrow and we'll look at monetary policy. All right. See you later.